So tree is the one of the most frequent asked question in case of MAANG interview. So if you are preparing for MAANG interview and if you are planning to master this particular tree, in this particular video, we are going to talk about three particular framework which will help you to solve any kind of tree problem. So what I have observed, so most of the time, so once people open tree problem, so they will read it once, they will reread it one more time. After that, mind goes blank, right? Sounds familiar to you? So here is what happens, right? You may not be bad at the tree, you are just trying to solve the tree problem wrongly. Most engineers, they memorize the solution of tree problem, right? They just solve one problem and they map it to one particular solution. Problem, solution. That's how they map, right? Hey, I am Vijay Vatta, AVP in a top tier 1 product based company. I had done my research work at IIT Delhi, right? So trained more than 1500 students and helped them to crack into product based company interview, worked in multiple countries. So today I'm going to show you something which is going to change your perspective towards the tree problem. We are going to talk about three framework here. And if you master these three framework very well, you will be able to solve 70 to 80% of the problems in case of LeetCode tree problem. You will never felt lost for any particular problem. Let's start this. Let me tell you what I see every day. What happens? What I have seen, every engineer, they will sit, they'll solve a problem, one tree problem, they will jump into another tree problem, then solve it, then they will just jump into other tree problem. But while jumping from one problem to other problem, they never create a patterns or they never create a framework out of that. They just solve the problem, jump into other problem, then they find it difficult, then they try to solve that, then they jump into other problem. So there is a difference, right? So if you are solving one problem, that means you are solving that problem. But if you are mastering a framework, that framework can help to solve maybe hundreds of problems, right, internally. When I was also starting out, I did this similar mistake. I learned in order, pre-order, post-order, all this, and how in order will work, how the pre-order will work, how the level order will work, how the depth, how to find depth of the tree, how to find height of the tree, right? How to, I mean, a lot of things, right? So I got confused with all these things until I realized the very important thing, which is the kind of framework. So in this video, we are going to talk about the three framework like we discussed. So let's start with the framework one. So which is the DFS framework, depth first search. So this is the most important framework in case of a tree. So DFS means you are going depth wise, depth until you come back from the last, right? So think it like a maze problem. So you will keep on going until unless you hit a wall, right? So once you hit a wall, then maybe you can come back or backtrack. So in tree, DFS is always done using the recursion. And remember, if somewhere you ask some problem, you can solve it using DFS, and you asked you to solve it using maybe iteratively, then obviously you need to go for the stack, because recursion is nothing but internally it uses a stack. But if you want to write the iterative solution, then it is going to stack. And once you master this particular DFS, right, understand the recursion, understand the master the DFS and the stack, then you will see that most of the problem actually embedded for this particular DFS problem. So here you can see the DFS skeleton, right? If you'll see, if there is a tree, most of the time you will get a binary tree. So that's why you can see, so that you need to do some operation or the traversal on the left hand side, and once it is done left, then you might need to go for the right hand side. And ultimately at the end, you need to return something, right? So when you reached any of the termination conditions. So in case of DFS, you need to ask three questions, right? So what are the three questions? First question, what is the base condition for this particular problem? That is what you need to first ask to yourself. Second question, which you should ask yourself, what exactly operation or how the traversal will look like on your left subtree and the right subtree, right? So that is what you need to think about it, how your traversal will look like, or the operation will look like, how the recursive structure will look like on the left and right. Third solution, which is the what is going to be the return value, right? That these are the three things if you ask, then you are going to be comfortable in this particular DFS. Let's talk about some of the problems that you can solve using this particular DFS, right? There are n number of problems. I'm just giving you a couple of examples here, right? So for example, in order traversal, pre-order traversal, post-order traversal, finding the maximum depth of a tree, right? Finding the diameter of a tree, finding the path sum of a tree, finding the lowest common ancestor of a tree, BST maybe. So before moving to the framework 2, I'll just tell you the biggest mistake that journalists, whoever is starting out or the freshers, they do. They use global value instead of returning some value within the method, right? And which will create a mess out of this. So instead of having a global variable, you can trust your recursion and you can return systematically, so that you will ultimately end up having the final value at the end. So let's jump into the framework number 2, which is the BFS, breadth first search. So as its name is representing its meaning, right? So breadth first search means explore one of the breadth, right? Or traverse in breadth wise, right? So this is breadth 1, then next, or you can say level wise also. Level 1, then level 2. Once all the nodes in this particular level 2 is completed, then you need to go for the level 3, right? So that's how the breadth first search works. So initially you need to find the root, then find all the children of that node, root node and process them, then find all the children's after that and process them, right? That's on a high level. Think it this like this, right? So if you are reading a book, like you are reading line by line, right? So one line is completed, then you are going to the next line. If next line, after completing the next line, you are going to the next line, right? So that is like a BFS, or breadth wise or the level wise traversal. So you need to be very clear when to apply what, right? So far we have discussed two framework, DFS, BFS. So whenever there is a need of like depth, or you want to go one side once first, then you need to return back, then depth is going to help you. Or if you get a signal like level or breadth wise traversal, or you want to go one by one level, right? So in that case, go for the BFS. So this is the skeleton. You can see what happens, right? So I mean, in this particular BFS, you will be using queue, right? In case of DFS, we used a stack or recursion, right? But remember this, in case of BFS, we will be using the queue, and initially we'll add the root node into this particular queue, and then once you traverse, then we'll keep on adding the next level nodes, and all this. This is going to be your framework, right? For any kind of level order traversal or BFS traversal. Again, there are so many problems can be solved using this BFS. Let me give you a small example, right? Couple of examples maybe. You can say level order traversal is one of the application of the BFS, zigzag level order traversal, then there are rotten oranges, right? So you might have heard, right? So I mean, where you can use the BFS. Then there are problems like right side view, then something like average of the levels, right? So these are some of the common problems, so which can be fall into category of the BFS, right? So one quick tip for the beginner, right? If you are getting started, there is a level size, right? If you look into the pseudocode very carefully, there is a level size. Every level you need to keep on find the size, and you need to stick to process that many number of nodes, because in the queue you are keep on adding, right? Dynamically the value of or the size of the queue is getting changed. So that's why at each iteration you must find what is the queue size or the level size, and you must actually consume that many number of nodes as part of that level. If you are a senior engineer who want to crack product-based company interview, then go ahead and book a free one-to-one call with me, where we will create a personalized roadmap for you. Now let's come to the framework number 3, which nobody is talking about, which is the return value framework. So it is one of the pattern or this like framework which help us to solve more harder problems. I call it as a return value pattern. So here is the idea, right? In case of DFS, when you call it recursively, then once there is you got into the bottom, then every function call will returning some value to its parent, and their parent will returning some value to its parent, right? So most of the time engineers, what they do, instead of not handling that value properly, they will be using a global variable, and which will make their code very messy. So in this particular pattern, let your sub-problem or the children give the responsibility to do their task and return the value to its parent, right? And its parent do its corresponding work, and whatever after computation, return it to value to its parent, right? So that's how every function are capable enough to return the value which they have computed, instead of taking any global variable or any other additional storage. Meaning in a high level, each node, right, compute their local answer and return to its parent. As simple as that. So here is the framework you can see, right? So here you can see, right? So what it does, right? So it is just trying to find out the maximum of left and right, doing a +1, right? That means at any level, it will try to find out what is the maximum of left and right, do a +1, and it will return to its parent, right? So this is just a small example, right? So that is the kind of framework you need to think and apply to a lot of the problem. You need to give the responsibility to corresponding node. So ask these two questions in this kind of pattern or the framework, right? So what does I need, right? Current node need from its left child or right child? That is the question you need to ask. And second question you need to ask, what I need to return to my parent, right? As a node, what I need to return to my parents. If you ask this question, right? So what I need to compute from my left side to right side tree, and once I get these two values, right? Maybe what I need to return. If you ask this question very carefully to yourself, you are going to master this problem. Again, there are a lot of problems can be solved using this particular framework. Like for example, finding the maximum depth of a problem, right? So maybe finding the diameter of the problem, right? Finding the path sum of the problem, lowest common ancestor. Now let's talk about how to know which framework to use when. Remember this keyword, right? If you see level, row wise or width wise, right? Then definitely that is going to be the BFS. If any time current node needs the information from both of the child in order to return something, then you can use the return value pattern. And everywhere else, right? You can actually use the DFS most of the time, right? So whenever you think you are going depth wise and you are doing some work. So these are the 3 lines what we talked about, right? So that is the whole motto of this particular discussion or this video. So don't be an engineer who generally solve one problem, so then they will memorize the solution and jump into the next one. Try to be an engineer who can use this framework in a better manner and try to develop some of your own thought process and framework. So we talked about the DFS, right? So which will go on depth wise, compute some value and keep on returning to its parent. right? Then we talked about the BFS, which is generally on the breadth wise or the level wise. Then we talk about the return value pattern, where the parent node will get some value from its left side, right side, and then do some operation and it will return to its parent, right? So next time, whenever you are picking any particular tree problem, try to get this particular signal and then try to master these three patterns, right? And they can apply that particular framework and get the answer. That's as simple as that. And if you're a senior engineer who is really serious to crack product-based company interview, then go ahead and book a free one-to-one call with me, where we'll create a personalized roadmap for you to crack this particular MAANG journey. If you want to see what is my 14 year of experience and how I moved from like kind of like students to kind of like MAANG level company, right? So here is the video. You must watch it, where I explain my 14 year of experience in this particular video. Thank you so much. See you in next video. Thank you.